Hello and welcome to ECE Electronics. Today's video is a gate preparation video and today we'll be doing the part 2 of digital electronics and logic circuit gate exam preparation. So this is your first question. Here you have to find the hexadecimal equivalent of a large binary number, and what is it you have to find? The options given are A. CD73E, option B. ABD3F, option C. 7CDE3, option D. FA4CD. This is a very simple question if you know hexadecimal numbers and how to convert binary numbers to hexadecimal numbers. So here you have to convert this, and in order to do that you have to pair four binary numbers or binary bits from this large binary number. So I'm going to pair the 4 numbers. This is the first 4 pair. 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, like this. Now you have to write the hexadecimal equivalent of this these pairs. The hexadecimal equivalent of these pairs have to be written, and then you will get your result. So let's do it. First number is 0, 1, 1, 1, which is equivalent to 7. Then 1, 1, 0, 0 is equivalent to C. 1, 1, 0, 1 is D. 1, 1, 1, 0 is E. Then 0, 0, 1, 1 is 3. So your result is 7 C D E 3. So this is the hexadecimal equivalent, a representation of your given binary number. So what is the result? The correct answer is option C. So option C is your correct answer. So the next question which we are going to discuss today is this. The Boolean expression AB plus AB bar plus A bar C plus AC is independent of the Boolean variable. Option A, option B, B, option C, C, option D, none of this. So in order to find the result of this question, you have to simplify the given Boolean expression first. So we will simplify the expression. I'm going to write it here. AB plus AB bar plus A bar C plus AC. So from these two terms, I am going to take A as common. A into B plus B bar plus, from the last two terms, I am going to take C as common. C into A bar plus A. So you know A plus A bar equal to 1 and B plus B bar equal to 1. So here A into 1 plus C into 1. So you can write A plus C. So this is the final expansion or result of your Boolean expansion when you simplify it. So the result is A plus C, and it is not having the expression of variable B. So here the correct answer here is option B. That is, the Boolean expression is independent of variable B. What is the minimum number of 2 input NAND gates needed to perform 2 input OR gate? So you can realize OR gate or any gate with the help of NAND gates. So how many number of NAND gates are required? That is, how many minimum number of NAND gates are required to create a OR gate? So you know AND gate is A dot P whole bar, and you know you have to create an OR gate which is OR equal to A plus B. So you have to form a plus B using NAND gate realization. So first you know you need 2 inputs. So I'm going to take a NAND gate and I'm going to short the input of the NAND gate, and I'm going to apply my first input as the input of my first NAND gate. Similarly, I have to take another NAND gate. I have to short its input and I have to apply my next input, which is B. Now you have, here it is A bar and here it is B bar. Take another NAND gate and apply this as the input of the third one. So what will be the output? At the output of your third NAND gate, you have A bar into B bar, the whole bar. According to the De Morgan's law, you can write this as A bar, the whole bar, plus B bar, that is A plus B. So which is nothing but your OR gate. So you got your OR gate realization using 3 NAND gates. So what is the minimum number of NAND gates required for OR gate realization? It is 3. So here the options given are option A1, option B2, option C3 and option D4. So you require only 3 NAND gates, which is option C. So option C is your correct answer. The Boolean expression AB plus A bar C plus BC equal to AB plus A bar C corresponds to dash. Option A plus B into A bar plus C into B plus C equal to A plus B into A bar plus C, which is your option A. Option B is AB plus A bar C plus BC equal to AB plus BC. Option C, AB plus A bar C plus BC equal to A plus B into A bar plus C plus B plus C. Option D, none of this. So there are 2 methods or 2 forms of representing Boolean expressions, that are sum of product form and product of sum form. So the given expression is in which form? It is in the sum of product form. So these are products and these are the sum. So the sum of these products are taken. So the given Boolean expression is in the SOP form, that is sum of product form, and it is equivalent to its product of sum form. So how will you write it in the POS form or product of sum form? I'm going to write it here. So product of the sum. So take the sum of AB, which is A plus B, and take the product into, or just convert the products as sum and the sum as products. That is A into C will become, sorry, it's A bar into C. It will be A bar plus C into, again BC will be B plus C equal to AB will be A plus B into A bar C will be A bar plus C. So what change has been come in this? So the sum of product has been changed to product of sum. So all the products in this has changed to sums and all the sums has been changed as products. So this is the POS form of this Boolean expression, and these two are equivalent. So while looking at the option A is same as the POS format, that is A plus B into A bar plus C into B plus C equal to A plus B into A bar plus C. So the correct answer here is option A. So the remaining expressions are not same because this is same as that of SOP form, but it is different from the given expression. Also here it is a mix of SOP and POS form, but this is the correct form here. You can also represent in the Boolean expression in various other forms, but for this particular question it is just changing the expression format, that is sum of product has been changed to product of sum. So here the correct answer is option A. This is the correct answer. The last question which we are going to discuss today is this. When two BCD numbers 0x14 and 0x08 are added, what is the binary representation of the result? Option A 0x22, option B 0x1c, option C 0x16, and option D result in overflow. So let's do the BCD addition and see what is the result. So the BCD format of 0x14 is and 0x08 can be represented as. Now add these two and the result will be 0, 0, 1, 1, 1, 0, 0, 0. So here the result is greater than 9. So in BCD addition, if the result is greater than 9, then add a 6 to the result. That is 0, 0, 0, 0, 0, 1, 1, 0. And the result will be 0, 1, 1 plus 1 is 0, 1, 0, 1, 1 plus 1 is 0, 1 here. So this is your final result, which is 0010 is 2 and 0010 is 2. So the binary representation of this result is 0x22. So the option correct here is option A. So these are the questions which I have included in this video. These are previous year questions which have been asked in GATE and also ISRO exams. So I hope the video is useful. And if it is useful, please don't forget to like it and also share it with your friends. And also don't forget to subscribe to the channel. Thank you.